A wilted tomato, yellow leaves curling at the edges, soil so tired it crumbles like old ash between the fingers. $200 spent on fertilizer this season, 3 trips to the garden center. And still, the plants are dying. But 3 feet below that failing patch of earth, a plastic bucket and a handful of small red worms can rebuild the entire garden, for free, in 90 days. No tilling, no turning a heavy compost pile, no back-breaking weekend work, just a quiet, buried laboratory doing what nature has done for millions of years, only faster and right under the roots. This is the strangest trash hack in modern gardening, and the gardeners who have tried it rarely go back. Part 1. The invisible crisis beneath our feet. What if the problem was never the plants? For years the advice has been the same. Water more, fertilize more, spray more, and yet the tomatoes stay small, the peppers refuse to fruit, and the green beans sulk in soil that looks healthy but clearly is not. The truth is harder to hear. Modern synthetic fertilizer works on a simple trade-off. Feed the plant now, starve the soil later. The blue crystals and white granules force a burst of growth in a few weeks. But the tiny living creatures that normally recycle nutrients in the ground, the bacteria, the fungi, the earthworms, go silent. Without them, the next season starts weaker than the last. The season after that, weaker still. The garden slowly forgets how to feed itself. This is not a small problem. The United Nations Food and Agriculture Organization has warned that roughly 1/3 of the world's soils are already moderately or severely degraded. When soil loses its living community, it loses the ability to hold water, hold nutrients, and grow food. It stops being soil. It becomes dirt. Why does no one say this out loud? Because selling healthy soil is hard. Selling a bag of blue crystals that turns a plant green in 48 hours is easy. The logic is economic, not sinister, but the result is the same. Gardens everywhere are quietly being fed to death. And here is a thought that makes some lifelong gardeners uncomfortable. The best garden is not the one with the most fertilizer, the most mulch, or the fanciest tools. The best garden is the one that needs the least help from the outside. That is a quiet kind of success. And it is almost the opposite of what every gardening commercial teaches. The fix is not in a bottle. It is not on a shelf in the garden center. It is sitting on the kitchen counter, in the coffee filter, in the eggshell, in the peel of last night's banana. Part 2. The quiet wisdom of retro gardening. Before synthetic fertilizer existed, how did any garden feed a family through the winter? The answer lived in every kitchen. Grandparents had no garden center to drive to. They had coffee grounds. They had crushed eggshells. They had the scraps from last night's dinner, the ashes from the wood stove, and the rinse water from the vegetables. And they grew tomatoes that would embarrass anything sitting under the fluorescent lights of a supermarket today. Take the humble eggshell. Rinsed, dried, and crushed into a coarse powder, the eggshell delivers calcium carbonate, the same mineral that prevents blossom end rot, that ugly dark patch that ruins so many tomatoes and peppers. Here is the first common mistake. Whole half shells tossed into a bed can take years to break down. Crushed fine, almost to the texture of cornmeal, they release their calcium over a few months. A simple coffee grinder, kept just for the garden, does the job in seconds. Then there are used coffee grounds. And this is where almost every gardening article on the internet gets it wrong. Used coffee grounds are not strongly acidic. The brewing process pulls most of the acid into the cup. What ends up in the filter sits near neutral, around pH 6.5 to 6.8, which happens to be close to the perfect pH for a vegetable garden. The real value of coffee grounds is different. They feed the microbes in the soil. They add slow-release nitrogen. They improve texture. But they do not lower soil pH in any meaningful way, no matter how often the internet repeats that myth. The horticulturalist Alan Titchmarsh has used these frugal tricks for more than 50 years. Banana peels, wood ash, nettle water, comfrey leaves, the lot. The Royal Horticultural Society in Britain has documented these kitchen garden methods for generations. None of it is new. Most of it is older than the compost bin itself. But scattered on the surface of the soil, these scraps can only do so much. Rain washes them. Ants carry them off. The sun bakes them dry before the microbes get a chance. The real transformation, the kind that turns a failing garden into a working one, only begins when someone decides to bury them. Part 3. The crazy trash hack revealed. A backyard alchemy lab. What happens when the compost pile is moved from the corner of the yard to directly beneath the tomato plants? Everything changes. Most gardeners have tried a traditional compost bin at some point. The problems are obvious. It sits in a sunny corner, smelling in summer. It has to be turned with a pitchfork every few weeks, which becomes almost impossible for anyone past 65 with a bad shoulder or a worn knee. And by the time the compost is finally ready, 6 months later, it has to be hauled in heavy buckets across the yard and spread by hand. There is a much quieter way. It has been used in experimental permaculture gardens for decades, and in some scientific circles it is called a subsurface bioreactor. That is a complicated name for a very simple idea, a backyard alchemy lab buried right where the plants are growing. The method takes about 10 minutes and costs almost nothing. Start with a food-grade plastic bucket, the 5-gallon kind that bakeries and delis will often give away for free. Drill holes at least ½ an inch wide all around the sides and the bottom. Here is the second common mistake nobody warns about. 1/4-inch holes are too small. Worms cannot easily pass through them, and plant roots have no room to enter. 1/2 an inch, minimum, larger is better. Dig a hole in the center of the garden bed, deep enough that only the top 4 inches of the bucket plus the lid stay above the soil. Drop the bucket in, backfill the earth around it. That is it. The bucket is now a permanent feeding station for every plant within a 3-foot radius. Every evening, kitchen scraps go straight in. Banana peels, used coffee grounds, crushed eggshells, tea bags, carrot tops, apple cores, wilted lettuce. Close the lid and walk away. No turning, no smell, because the lid stays shut and the food is below ground. No pests, because raccoons and rats cannot reach what is sealed and buried. For gardeners who prefer something beautiful over something practical, an unglazed terracotta pot works even better than plastic. Terracotta is naturally porous. Liquid nutrients, often called leachate or compost tea, seep slowly through the clay walls into the surrounding soil. A quiet drip feed that lasts for weeks on a single filling. 2 stacked terracotta pots, one inverted on top as a lid, become a miniature alchemy tower that can last in the garden for a decade. Here is a small, uncomfortable truth worth mentioning. Most bagged compost sold at the garden center is sterilized. The high-temperature treatment kills weed seeds, yes, but it also kills the vast majority of the living microbes that make real compost work. A buried bucket, fed daily with fresh scraps, produces something a sealed plastic bag never can. It produces living compost. But the bucket itself is only the structure. What actually eats the scraps, and this is where almost every new convert makes the single biggest mistake, is where the story gets strange. Part 4. Why most garden worms die in a compost bin. Why do so many people who try this exact method fail on the very first attempt? Because they put the wrong worm in the bucket. Walk into any bait shop in the country and ask for worms. The tub on the counter will be full of big fat night crawlers, scientifically known as Lumbricus terrestris, the worm most people picture the moment they hear the word. Drop a dozen of them into a compost bucket, pay $12 for the privilege, and within a week, most of them will be dead. The reason is biology, not bad luck. Night crawlers are deep burrowing worms. In the wild, they live in permanent vertical tunnels that can reach 6 feet down into undisturbed earth. They eat soil and dead leaves from above, pulled down at night. They do not eat fresh kitchen scraps. Put them in a shallow, food-rich compost environment, and they panic, overheat, and die within days. The worm that actually belongs in the bucket is smaller, redder, and almost never sold at an American bait shop. Its name is Eisenia fetida. Most gardeners know it by a friendlier name, the red wiggler. Red wigglers are what biologists call epigeic, which is a fancy word for surface dweller. In the wild, they live in rotting leaf litter, forest floors, and old manure piles. Exactly the kind of environment that exists inside a buried compost bucket. They thrive in it. They eat close to half their body weight in waste every single day. A single pound of red wigglers will process a pound of kitchen scraps in 2 to 3 days. What they leave behind has a nickname serious gardeners have used for over a century: black gold. Worm castings are nothing like raw compost. They are concentrated, water-soluble packets of nitrogen, phosphorus, potassium, and a living cocktail of beneficial microbes, perfectly balanced and in a form roots can absorb immediately. The results are hard to believe until they are seen. A 2019 meta-analysis of dozens of independent vermicompost trials found average yield increases of around 26%, biomass gains of 13%, and a staggering 57% increase in root mass. Cornell University vermicompost research has documented some vegetables showing up to 50% yield gains when worm castings replace synthetic fertilizer. A pound of red wigglers costs about $30 online, and that is a one-time purchase. Within a single season, they double their population. Within a year, the garden has a self-renewing workforce that never takes a day off, never asks to be paid, and quietly turns what used to be trash into something worth more than most products in the garden center. But the red wigglers do not work alone down there. Something far smaller, far stranger, and far more powerful is doing even heavier work, and almost nobody in the gardening aisle ever mentions it. Part 5. The Invisible Architects. What actually builds the crumbly chocolate cake soil that every serious gardener spends a lifetime chasing? The answer is probably not what most gardeners would guess. It is not the worms. It is not even the compost itself. It is something invisible to the eye. Deep inside the buried bucket, a microscopic transformation is underway. Bacteria arrive first, fast and hungry, breaking down the soft sugars in banana peels and apple cores. They work quickly, releasing heat and simple nutrients. A fresh bucket can warm to over 100 degrees Fahrenheit in the first days, entirely from microbial activity. Then the fungi move in. Fungi handle the tougher jobs, the woody stems, the cardboard, the coffee filters, the fibrous things bacteria struggle to break. One group of fungi in particular, called trichoderma, does something remarkable. It breaks down tough material while also suppressing the soil-borne pathogens that cause root rot, damping off disease, and stem canker. A free, round-the-clock bodyguard for every plant in the bed. Close by live the mycorrhizal fungi, the single most important garden partner most home gardeners have never heard of. These fungi connect directly to plant roots in a true symbiosis. They extend thread-like strands called hyphae deep into the compost bucket, mining it for nutrients and delivering them straight back to the plant in exchange for a tiny bit of sugar. A tomato plant connected to healthy mycorrhizae effectively has a root system 50 times larger than what is visible. 50 times. That is the difference between a plant that wilts at the first hot afternoon and a plant that stays turgid through a week of drought. And then there's glomalin. This is the detail that almost never makes it into a gardening book. Glomalin is a sticky, glue-like protein produced only by mycorrhizal fungi as they grow. It coats soil particles and binds sand, silt, and clay together into small, stable crumbs. That crumbly, rich, chocolate cake texture that every gardener tries to achieve for decades, that is glomalin, and it only forms where the fungi are alive and working. No fungi, no glomalin, no crumb structure, which is exactly why chemically sterilized soil stays hard and cracked, no matter how much fertilizer is poured into it. Here's where a lot of old-school gardening wisdom begins to look questionable. Every spring, millions of gardeners turn over their beds with a shovel, a fork, or a rototiller. It feels productive. It looks neat. It also shreds the fungal network that took all of last year to build. Every spring tilling session is, in a very real sense, tearing down the invisible infrastructure the garden needs to feed itself. A buried bucket system, by contrast, never disturbs the fungi at all. The scraps go in from the top. The network stays intact underneath. The final product of all this quiet work is humus, the dark, spongy, sweet-smelling material that can hold up to 90% of its own weight in water. A single 5% increase in organic matter can quadruple a garden's ability to store water during a summer drought. For the gardener with a sore back and a heavy hose, this is the real quiet miracle of the whole system. Less watering, fewer emergency rescues during heat waves. More forgiving soil, season after season. And for those who want to push the system even further, the entire living community inside that bucket can be concentrated into a liquid that sprays directly onto the leaves of a dying plant. Part 6. Brewing the elixir. Aerated compost tea. What if the soil's entire living community could be brewed like tea and sprayed onto dying plants? That is exactly what aerated compost tea does. Think of it as taking the best parts of the buried bucket, the bacteria, the fungi, the microscopic protozoa, and multiplying them 1,000 times over in a bucket of water. The result is a golden, earthy-smelling liquid that, when sprayed onto a struggling plant, coats its leaves in a living armor of beneficial microbes. Dr. Linda Chalker-Scott, an extension specialist at Washington State University, has cautioned that compost tea is not a miracle cure. There is no silver bullet in gardening, but she has also documented that under the right conditions, compost tea can suppress certain plant diseases and give weakened plants a meaningful boost. The brewing is simple, but every step matters. Start with 5 gallons of clean water in a food-grade bucket. Here is a mistake almost every beginner makes. Municipal tap water contains chlorine, and chlorine kills the very microbes the tea is supposed to multiply. There are 2 easy fixes. Leave the water out in an open bucket for 24 hours. The chlorine will evaporate on its own. Or crush a single vitamin C tablet into the water. The ascorbic acid neutralizes the chlorine in about 15 minutes. Add 2 cups of high-quality worm castings tied inside an old pillowcase, a cheesecloth, or a mesh paint strainer bag. To feed the microbes through the brewing cycle, add 2 tablespoons of unsulfured blackstrap molasses. Molasses feeds the bacteria. For the fungi, add a spoonful of liquid kelp or fish hydrolysate. The amino acids and complex carbohydrates cause fungal populations to explode. The final essential piece is an ordinary aquarium air pump with an air stone. The pump forces oxygen steadily into the brew, which allows aerobic microbes, the good ones, to multiply wildly. Skip the pump, and the same brew turns into a foul, rotten, anaerobic sludge within hours. The nose tells the whole story. Sweet and earthy means the brew is alive and ready. Sour, rotten, or ammonia-like means dump it and start over. After 24 to 36 hours of steady bubbling, the tea is ready. It has a short shelf life. 4 to 6 hours once the pump is turned off, because the microbes begin to starve for oxygen. Spray it onto the leaves at dusk, when the sun will not burn the living microbes. By morning, the plant has a protective shield of beneficial organisms outcompeting any disease for space. And once a garden has this kind of daily, weekly, quiet support, something unexpected begins to happen. Part 7. When the garden stops needing the gardener. How does a person know when the system has truly taken hold? After a few months, the soil begins to change in a way that is hard to describe until it is felt underfoot. It becomes dark, it becomes soft, it smells faintly sweet, like a forest floor after an autumn rain. The worms multiply on their own. The fungal networks spread quietly through the bed. The plants start to drink less water and produce more fruit. Weeds, strangely, seem to struggle more than the vegetables. Some gardeners add one more layer at this stage, a product called effective microorganisms, often abbreviated EM, developed by the Japanese professor Teruo Higa in the 1980s. EM is a carefully blended mixture of beneficial bacteria, yeast, and fungi, designed to accelerate the transition from dead dirt to living soil. It is completely optional. But for a garden that has been abused by years of synthetic chemicals, EM can cut the recovery time roughly in half. After a full growing season, the strangest and quietest realization settles in. There is almost nothing left to buy. No fertilizer, no bagged compost, no synthetic pesticide. The kitchen trash has replaced every expensive product on the garden center shelf, and the garden itself has quietly become the product. Neighbors start noticing. They ask what the secret is, and the answer disappoints them every time, because they wanted a product name and a shortcut. What they get instead is a buried bucket, a handful of worms, and a little patience. The bucket, buried and forgotten, keeps working, year after year. Conclusion. Look at the garden now. The yellow leaves are gone. In their place, deep green tomato vines climb their stakes, heavy with ripening fruit. The beans produce so much that neighbors start finding bags left at the door. The soil, once gray and tired, is now dark, alive, and fragrant in the cupped palm of a hand. All of it came from a buried bucket, a handful of red worms, a kitchen that used to send its scraps out in a trash bag every Tuesday morning. This is the part worth sitting with for a quiet moment. The Japanese farmer and philosopher Masanobu Fukuoka once wrote that the ultimate goal of farming is not the growing of crops, but the cultivation and perfection of human beings. A garden like this one cultivates patience. It rewards quiet observation. It returns, in food and beauty, whatever care is given to it. Anyone watching can begin this week. 1 bucket, a drill, a half-inch bit, a handful of red wigglers. 90 days of waiting and watching. And when the first real tomato of the season comes in the size of a softball, there is only one question left worth asking. What else in this life has been thrown away that was always worth more than anyone realized? Thank you for spending this time in the garden. Keep growing, keep wondering, and always remember to nurture your roots.